Hello universe. This is Zahra M.M.A. Sadiq. The complexity of machine learning tasks depends on the amount of data which is connected with the number of possible combinations. As a result of a high complexity, the time and costs of the procedure increase. If it was possible to reduce the complexity of the machine learning task, you could save time and computational resources. I'm going to explain a technique which allows reducing the complexity and finding the appropriate algorithm for your task. If the formula you calculate is simple, the error concerning the bias increases. If the formula is complex and contains a large number of mathematical terms and parameters, the variance of the predictions is too high. If the function is very complex, the output is only appropriate for the particular data set. If the set changes, the prediction is not appropriate. Reducing the parameters of the function avoids data overfitting and improves the generalization. It is possible to solve the task by choosing an algorithm which calculates an appropriate amount of parameters. Because the structure of the data determines the quality of the performance of the algorithm, it is useful to define their adequate relationship. It is useful to facilitate the process as much as possible by deleting parameters which are not necessary. This technique is called Occam's razor. I divide the data into a training dataset and a test dataset. Learning curves are part of the Scikit-learn machine learning library for Python. Two curves which represent the errors are the result of the training. These curves exist for the bias and the variance. They facilitate the adjustment of the algorithm. If the point which represents the converging of the curves is high, this indicates that the bias is too high. It is possible to solve the problem by choosing a larger number of parameters or a more complex algorithm. It is possible to use a reduction technique that decreases complex structural dependencies and which supports tractability. It facilitates the structured prediction and improves generalization. In order to advance the predictability, one decreases complex structural dependencies to reduce the error rate, noise, and overfitting. This is achieved by using a simple structural complexity regularization solution based on structure regularization decoding. To improve the generalization ability of the model, the complex structure is regularized by the simple structure. The method applies structure regularization decoding algorithms for several important natural language processing tasks that include sequence labeling tasks and parsing tasks. This technique uses an LSTM network which performs the sequence labeling tasks. It applies a hierarchical model like the perceptron model for the parsing task. The sequence labeling task finds a label sequence with the maximum probability. The procedure estimates the joint probability of the labels in the sequence of words, that is the condition. The number of parameters that is estimated for modeling the joint probability is large, and this makes the task intractable. Markov assumptions reduce the parameters and make the procedure tractable. Dependency parsing aims at predicting the dependencies among normal words. Structural complexity regularization decomposes the dependency scope of the training samples into smaller localized dependency scopes that form small samples for the learning algorithms. Complexity is the number of computational steps which an optimal algorithm needs to find the solution for a given task. I use Floyd's algorithm to calculate this complexity. The steps 1 and 2 calculate the steps which are necessary for the transfer from the data D1 to the data D2. The second step consists in calculating the minimum number of iterations of the transfer from D1 to D2. For example, for a given task, the runtime increases proportional to n. This is called the linear complexity. The input value determines the runtime of the linear task. The last 3 steps calculate the value of eta. Eta is the level of incremental data which indicates the risk of assigning the data D to cluster P. The complexity of machine learning tasks depends on the amount of data which is connected with the number of possible combinations. It is possible to find an appropriate technique which allows reducing the complexity and finding the suitable algorithm for your task. It is possible to solve the task by choosing an algorithm which calculates an appropriate amount of parameters. One technique applies structure regularization decoding algorithms to reduce the complexity. It is possible to use Floyd's algorithm to calculate this complexity.